So, good morning. This Monday, we already have the discussion finally about the IP addressing and specifically talk about the hierarchical addressing. And later, we will have one TPS to ask you to have the exercise, how to have the address block partition. Of course, finally, we already have this one in the class of Monday, talking about where we can have the addresses. Actually, we have the addresses assigned by the association of ICN. So this is the discussion content for today. We will have the further discussion. We want to talk about network address translation. Network address translation, then in shorthand, we will have NAT. Alright, so of course, we will have the exercise using one thin pair shell. But before that one, let us have the discussion about NAT. Network address translation. Well, why we want to have the translation? In fact, I should let you know we have DHCP. Therefore, we have the public and private IPs. We have the range to have the public IP. And also we have the range of private IPs. You can look up, for example, you can ask maybe ChatGPT to that have the range of the public IP and the private IP. Well, because of public and private IP, and also because of the IP assigned by DHCP using the private IP. So we should have the translation. Well, I assign you an IP. Of course, we have the association with one possible public IP, but we should have the translation. Because of the reason here, we need to have the translation. You see, here this is the private IP. Alright, so we have the private IP, but we should have the association of a public IP to the outside of the world. Oh, sorry, should be this. You see, we'll have the IP to the outside. Here, this is a public IP. Alright, so we should have the association. Public IP here to the outside, and from the outside we will return to the public IP to the app or to the process, and then we need to have the mapping. Well, why we should have the mapping? Because of public and private IP, and also you see we have the mapping, and of course here we have the private IP, and you can find which range we can have for the private IP and how to have the mapping. Later we will have a table. In fact, we have one public IP. How to have the mapping? Because possibly you have many apps. So we should have the different port number as well. Therefore, one public IP and many port numbers, and so that we can have the mapping, one-to-one mapping. I emphasize if we have the IP and port number, so that we have a one-to-one mapping. If so, then we can reverse it, right? Something like we have a function, and the function can have the reverse function, we should have the requirement one-to-one mapping. All right, so we have the one-to-one mapping, then that's fine. So I think up to now, that's it. That says, okay, we have one IP possibly, and maybe you can have the other, but at least we focus on one IP and many port numbers so that we can have the mapping. And if we consider NAT using the private IP, then we can have the advantage of security. Why? Because you don't know my IPs explicitly, only the public IP. However, for the inside, something like we have here, we have the shielding wall, and so that to the wall only. As for the remaining, no, we don't know the further information except the translation by NAT. Well, so this is a concept of NAT. We need to have the IP address translation from private to public or from public to private IP, along with the port numbers. If we don't have the port numbers, then we cannot have the one-to-one mapping. Well, if so, then just a mapping table. Therefore, we have the address translation. Well, you see, for the outgoing datagrams, or maybe you call it is the packets, we will replace the original source. Alright, so we will replace the original source IP. Also the port number. So we have the original IP and port number replaced by the outgoing IP. Here, the NAT IP address is the public one. And to the new port number, because we need to have the mapping. Alright, so this is the main idea. As for the reverse direction, because of one-to-one mapping. So don't worry, you just pass on the current mapping, then we can find the possible mapping. Well, for we should have the table. We have the NAT translation table, and pass on source IP port number to the NAT IP address and port number pair. So we can have the translation for each side. Well, up to now, we start from outgoing, right, to the table. And for the incoming, that says the reverse direction. The reverse direction using NAT IP address, previous new port number. Well, we use a translation table, we can find, oh, the original IP should be, and the original port number should be. And so we can pass on the table to have the translation properly. Therefore, we have a term corresponding. Because of the mapping, so we have the corresponding original source IP and port number stored in the NAT table. Well, this is a concept and the implementation. And we use the current figure to have the illustration. Look at this. Outgoing, right? And the original IP or source IP is the private IP. And we want to have the destination IP, so this is the destination. Destination public IP. Alright, but we don't want to use this. So we have the translation. The translation here, not the destination, it's the NAT IP. Alright, so we want to have the private IP send it to the destination IP, but the destination IP is the current IP we want to have the association. The association should be the NAT IP address. Well, someone like I'm an NAT, right? I have my IP address associated with my address, NAT IP address. Well, so we have the translation and using this public IP to stand for my process. And how to return? For the destination, you should use the current NAT IP address and port number, and so that it can identify my process. So return then, oh, okay, get back to this and pass on the mapping, and then we can have it. Well, maybe you have a question for the reverse direction. Why we don't want to have a different role? It won't be necessary because the current one is a role to have the mapping, and then that's done. So it won't be necessary for us to have a different row or different entries. Well, this is the current idea of NAT translation, network address translation. Before we go, maybe let me stop here and let you have 1 minute to think about NAT translation, and feel free to discuss with your neighbors. So feel free, it doesn't matter. I just want to allow you to have a chance to think about this. And you can have further notes for NAT for sure. Alright, so this is NAT. The core concept should be translation from private IP along with the port number to public IP along with the port numbers. And vice versa, we have the one-to-one mapping. And right now, we have one problem we call NAT has been controversial. Controversial, what it means? Here. Why? Current discussion we talk about network layer. Alright, but we have a port number. Therefore, this is a problem for network layer. The network layer should work with the app layer. Why? The current layer can work with the app layer. I think you can think about this, it doesn't matter. When we talk about the transport layer, we still need to use IP. And currently for NAT, even we talk about the network layer, we still want to have some information from the transport layer. So this one, you think, okay, somewhat strange, but it's still okay. You see, router should only process up to layer 3, we should have the other issues. And because of the port number, right? Because of port number, you think, okay, you don't like it. Up to layer 3 says up lower layer to layer 3 only. That says we want to have the discussion about the fourth layer, the transport layer. So the current problem coming from this. The port number. Alright, so the port number. Okay, so I think even you don't think it's a problem, but we have the discussion for you, port number. Port number and network layer IP. So this one you think, oh, that's okay, but for the current discussion, we think it's a problem, somewhat strange. However, we use it for sure. Even someone thinks it is not a natural one, but indeed it's a natural one. Well, that is the first one. Port number associated with the translation. It doesn't matter. But this one, it is not a problem. However, we want to have the reverse idea. Maybe you don't let me have the translation. Maybe we have the translation, but I want to find someone within or under the NAT routers. So how I can find the translation? If I don't have any experience to have the translation table, then I don't know what's the public NAT IP address. So we don't know that one. And then we need to try to find a hole and dig in a hole to find, oh, okay, I know the translation. If you want to do something like that one, it is called NAT traversals. Right, traversal. For example, we have one problem. We try to have a server behind an NAT. Can you find it? If you don't know the public IP, no. Or maybe if you, even you know the NAT address IP, you don't know the port number. If you don't know the port number, you cannot find the mapping to contact the server process directly. So you need to try, for example, even you know the IP address. How about trying port number 1, 2, 3, 4 to the other? Finally, okay, I got response from the server. Something like that process called the traversal. 我刚刚说，其实说我根本不知道后面他用了什么 port number， 结果我要去试的这个过程就叫 traversal。So we have one possible process called NAT traversal required for NAT translation. Well, you see, even we have a possible issue associated with NAT, still we use it. So that's why NAT is here to stay. We use it. Why we want to use it? Previously, we talked about IP addresses for IP version 4, IPv4, and we don't think we have enough IP addresses. But NAT is serving as a possible solution. Because of the solution here, so that's why we have NAT is here to stay. Alright, so NAT is here to stay. That's good. And also because of the translation, so we can have the DHCP, and therefore we have this, right? DHCP. So home or DHCP, and 4G, 5G, all the other networks, and so that it's easier for us to have the mapping. And we can reuse the addresses along with the port numbers. Well, that's it. So this is the extended discussion after the IP addressing. So we didn't have NAT first, and later we will have the possible exercise along with NAT for sure. But let us have the antenna checking, and this time I didn't have this directly. So go and check it for 2 minutes. So for students in the classroom, I think almost done, right? And we still need to have the actual time for students online. So wait for 50 seconds and later we can continue. All right, so let me move on to the next page. So this is a problem for us. And this time, yes, we reorganize the group 1 here. Maybe today we don't have a group 2 in the classroom, and perhaps group 4 together. And group 6. All right, so this is the first problem. Asking you to have the address partition. All right, and join group 1. For you, join group 1. So the current problem saying, oh, we have a router interconnects 3 subnets, subnet 1, 2, 3, and then we have the original address block with the prefix 24 here. And we ask you subnet 1. Required to support at least 60 interfaces, and subnet 2, 90. And the subnet 3, 12. So 12, 90, 60 for the hints. If 12 using binary numbers to include 12, so it should be 16, right? And 60, it should be 64. And 90, it should be beyond 64, so it should be 128. All right, so here you see you have the possible number. Based on the possible number, the current problem asks you to have the decimal and binary translation. We already have the decimal here. We ask you to translate the decimal to the binary IP addresses. And so that you can use 64, 128, and 16, and how you have the proper partition. So here we already have a hint. All right, and about the hints, I think right now you can look up our line group about TPS1. TPS1 actually is the entry to the thin pair shell. Of course, if you don't like that one, you can scan the QR code. All right, then you have 5 minutes to work with your team members. Okay, so let's go. Sure, you can find some information first, or maybe you can work together. And of course, later I will choose one possible member to share your idea, or maybe finally you solve it. That's good. later try to invite Yuxiang. Later you can share with us. Who is Yuxiang? Not here? Okay. So, forget it. I will invite one member in the classroom. So let me make sure students in the classroom. Anyone want to share and serve as the presenter? Anyone want to do that? Yes or no? If no, maybe let me try to use the results from Yuxiang to have some discussion further. Well, maybe this one. Alright, so for this one, Yuxiang says we need to reserve 2 IPs. Actually, no. We do not ask you to have the reservation, so it won't be necessary to have the cancellation. No. It won't be necessary to have two extra IPs. You just consider, oh, okay, we have 90, 60, and 12. So currently, it won't be necessary to have the extra one to have 14, 62, and 92. No. And actually still the same, we have 128 and 64 correct and 16 correct. Well, so for 16 we have 4 bits. 4, it's 4. So we have 4 and this one we have, 16, sorry. Yeah, we have 4 bits. And 16, we have 4 bits. And 64, we have 6 bits, right? And 128, we have 7 bits. And so that based on this, how we have the assignment for all of these. You can pass on the binary to have the partition. As for this one, correct or not, I think just for your reference. Alright, so this one I think you can continue because no one wants to serve as a presenter. I just want to have the discussion and ask you to think about how many bits, and so that we can have the partition. And as for the partition, if actually you should base on binary number to have the partition. Alright, so this is the first thin pair share. Well, today maybe I use Yuxiang's content to have some further discussion. In fact, I don't have some actual information. I just let it know, yes, we have the necessary bits to denote these and how to have the partition. All right, so this is the first TPS. About the TPS, I think you still need to have your own time to get it done. Or maybe let me make sure for all of you finish it. Yes or no? Do you have the answer already? If yes, you can upload your answer to the Padlet and so that I will ask here to grade later. But generally, you are allowed to have the answer till 4 p.m. as usual. All right, so this is the first problem because we need to grade. So I already have the hint and I will release the solution after 4 p.m. today. And next one, we have two problems from questions, not the problems. But I call the two questions here, or maybe two questions here, problems. First problem and second problem, and maybe about NAT here, right? NAT or maybe no. And so about the two problems this time, I try to ask good 1 and 4. Think about the, Good 1 and 4, thinking about the first problem. And good 6, dedicate to the second problem. Later, if yes, you want to have the idea sharing. Some of you can serve as a presenter. All right, so this is the second thing, pair share. And likewise, you can share our line group to find the entry so that you can visit the Padlet. But let me start here and allow you to scan. And of course, then you have 5 minutes again to have the discussion with your neighbors. Maybe let me switch back to make sure everything's okay. So let me try to invite some of you to serve as the presenter to share your ideas. And about problem 1, good 1 and 4, anyone want to share? If yes, upload your answer first, or maybe upload your idea first. Of course, you can modify later. And the second problem from good 6, yes, if some of you want to share your idea, same, upload your answer first. 1 and 4 for problem 1, and good 6 for problem 2. One and 4, anyone want to share? Just share your idea. So 1 and 4, yes or no? Guarantee no. And how about good 6? Okay, so wherefore some of you for problem 1 from good 4. All right, so let me transfer the mode to demo mode. And later we will have one presenter for problem 1 from good 4. And how about good 6, yes or no? It doesn't matter, just share your idea initially. Of course, you are allowed to have the possible multiplication later. So let me try. Okay, this way.
The first question, our answer is 10 because router has in and out, so there are 4 routers, so 4, so it's 8. And the host have 1 and we have 2 hosts, so it's 2, and 8 plus 2 is 10. And then the second question is 4 times because there are 4 routers.
Okay, thank you. So this is idea shared by Guanzi, talking about the first one. And actually, we have some answer from students online. And let me check the answer from Quentin. At least for the second subproblem. Maybe same as the Guanzi's answer. As for the first one, maybe we need to check it later. Alright, so this is a presentation for problem 1. For all of you, you should have the answer for problem 1 and 2 simultaneously before 4 p.m. About the presentation, of course, I assign one problem to some of groups to have the presentation only. So it doesn't mean just focus on the assigned problem. Alright, so this is the discussion from group 4 about the first problem. It doesn't mean why I don't want to let you have the answer, because we still let you have time till 4 p.m. So after now, I cannot release the solution immediately. So no comments for the possible idea sharing. But maybe some same, or maybe you can refer to some of those. Perhaps we don't have the idea sharing for good 6, or maybe at least we don't have enough time. But let me have a summary for today's class. We have the NAT translation. And after that one, we have 2 thin pair share. And if you don't finish the 2 thin pair share, don't forget to upload your answer before 4 p.m. today. And that's a discussion for today's class. And likewise, let me make sure any questions. If no, see you next week. Bye-bye.